Alright, now let's think about the front end. So the front end, I'm not going to worry too much about the resistor values of the front end, and I'm mostly going to spend my time worrying about the current impairments from these two inputs here, and also the offset voltage. So the LM324 could have 2 millivolts of offset voltage between these two inputs. So we could have 2 millivolts here, and we could also have 2 millivolts with an opposite sign over here, which could add up to a total of 4 millivolts of input offset. And again, these aren't always going to be exactly 2 millivolts. It could be all over the place. But sort of a bad case that we could expect is to have a total of 4 millivolts of DC offset just from the offset voltage of these op amps. And that then goes into my back end stage and gets gained up. So this 4 millivolts that we could have over the inputs is going to get multiplied by the gain of the entire in-amp. So let's say we have 4 millivolts here and the gain of the entire thing is 1000. We're going to end up with 4 volts at the output. And since the output changes volt for volt with the DC offset correction knob, that means we're going to have to turn that knob 4 volts just to cancel out the offset voltage between the two inputs. And my power supply was only going plus or minus 9 volts away from ground, so 4 volts is a pretty significant chunk of that. And keep in mind that's also just an average case. It could be worse, or also better. Then we also have these current impairments that we haven't thought about yet, and both of these inputs are connected to ground through my body using my body as these two resistors. Now these are going to be pretty large, and it's going to be useful to actually measure the resistance of my body to actually calculate what these impairments are going to be. So right now I have a couple of pennies taped on, one right in the middle of my chest, right in between where the electrodes were, and then one sort of down and off to the side where that ground electrode was. You can see I have about 10 mega ohms of resistance, and when I push on them I can drop that down to something more like 2 mega ohms, maybe less. So now that we've got those measurements, let's see what that means for our DC offset impairments. So if these two resistors are equal, which they're of course not going to be, but let's pretend they are for now, then the bias current is not going to matter because it'll cause the same voltage drop over both of them. So what's important for right now is the offset current, which is 5 nanoamps. Now these resistors are, let's say 5 mega ohms on a good day. So multiply that by 5 mega ohms. That's going to give us a voltage of 25 millivolts between these two inputs. Now that gets gained up by 1000, and we're going to need 25 volts on that VREF in order to correct that, which is really not possible with that plus minus 9 volt supply that I had, obviously. Keep in mind that there's also a much larger bias current, which is something like 47 nanoamps, and that will get multiplied by the difference in the two resistors and create another voltage that might or might not cancel this out. So when I was pushing on these electrodes to correct the DC offset or control the DC offset, what was probably happening was that I was adjusting these two resistors so that it would actually balance the voltage between these two and cancel out this impairment. Now that's obviously not good enough for a final circuit, but I think I've narrowed it down to the front end as the cause of all my DC offset problems. So I'm going to use some much higher quality op amps for the next iteration of this circuit. I'll call it the Mark III. And here I have the datasheets for another op amp chip that I have lying around, the TLC272. This has a much better offset voltage than the 324, around 400 microvolts, just like an order of magnitude less than the 324. I'll have to look a little bit deeper into the data sheets to see its offset current and bias current, which are on the order of tenths of picoamps, or at most tens of picoamps. And the reason for that is because this chip uses MOSFETs instead of BJTs, which have very little current, basically no current flowing into the inputs at all. So this chip only has 2 op-amps on it, but that's fine because I only need 2, since I've already figured out that I can use those crappy BJT op-amps for the back end and still be able to cancel out their impairments pretty easily. So long story short, most of my DC offset problems were caused by the BJT op-amps that I was using, having pretty large offset voltages and offset currents. So I did figure out that I can still use the BJT op-amps for the back end, and probably some other stuff that I add on later, which is nice because they're cheaper. But the front end is much more critical, and I need some op-amps with much lower bias currents and offset voltages. And to use the highly technical engineering jargon, these BJT op-amps are dog shit. So that's where I'm going to leave it for this video. And in the next video, I'll build up the Mark III with the new fancy op-amps at the front end.